and that is going to show up all the way back over in the JavaScript here on toBrowser, and that's going to be sent to the browser. And then on reception, it is going to, hey, we've got a new update block. Everything in the two browsers is sent to the appropriate socket. The socket sends it to Flash. Flash puts it out on the socket. Works like a charm. So, you might be thinking, Dan, wait. You've got a bucket at one domain, and you've got these sockets that are at a completely different domain. How come they're allowed to talk? You told me earlier that if two things aren't from the same domain, they're not allowed to talk. But there's this wonderful little exception in same origin policy. I'll totally use all of this stuff to my advantage. It turns out that if a parent frame and a child frame each are in the same, if a parent frame and a child frame are each in the same subdomain, they can both claim and actually allow access to each other. So what happens is my domain in this case, proxyhost.com, or I guess notmallory.com. Why not Mallory? Because seriously, it's not Mallory. It's not a bad guy. What? Why are you looking at me that way? Not Mallory may have bucket.notmallory.com and may have 1.2.3.4. Whatever random value.notmallory.com. But if they both claim to be in the security domain, not Mallory, they'll get the script against each other. Thank you, same origin policy. And that's it. A little bit of housekeeping for opening and closing sockets and eventually entire sockets. Literally, when the second level iframe is no longer useful, it just disappears and is removed from the DOM. It's very weird to be in a telnet session and hit enter and then your web browser just starts losing entire objects. Kind of cool though. Haven't talked about the attacker. I haven't talked to you about how it is that the attacker actually gets to open up connections on the proxy. By any chance, let me do a quick time check here. By any chance, was anyone at my first BlackHat talk? Awesome. That is some old school. All right. So Grandma actually made cookies, and I'm going to give them out to anyone who asks a good question. If you were one of the guys at my first talk, you deserve cookies. It was like 7 years ago. All right. First talk, I talked about this thing using Slurp. Slurp used PPTP over SSH. Slurp was a 1995 era tool that turned shell connections that were text only into PPP connections. PPP, of course, standing for pretty pictures. Grandma, I used Slurp on the machine you bought me. I talked about Slurp in 2001. Slurp was old school when I was at my first BlackHat. I don't even know what it is now. What Slurp actually does is, given a stream of packets, create sockets and send the data in the packets to those sockets. Slurp was a user space NAT implementation. Slurp, the most modern version of Slurp, is actually not on the internet. I searched for it for like an hour. And then I'm like, wait, there's no way I don't have it in my archives. I started looking at old hard drives. And sure enough, there we go. So I'm republishing Slurp. I'm bringing Slurp back from the dead. Hell yeah. Check this out. We've got a PPTP daemon. I am so not restating how PPTP works. It's the most hideous protocol on the face of the planet. And that's saying something. I've seen some pretty bad ones lately. In fact, I think I just wrote one. But what PPTP ends up doing from the client perspective is it takes all the packets that are going on, all the sockets, takes everything that would go out to wherever, shoves it all into a PPP stream and sends it at an individual address. PopTop, the Linux PPT daemon, strips off all of this encapsulation and just yields a PPP session. Well, PopTop can talk to Slurp. So PopTop can say, here Slurp, here's a bunch of packets, please turn them into sockets and go do some good stuff. What if we were to modify Slurp a little, that instead of doing its own sockets, it went to Slurpy? And it said, hey Slurpy, why don't you find a web browser somewhere to go ahead and complete my sockets? That's actually why it's called Slurpy. It bridges slurp with IE. Oh yeah. So, our final idea here, the attacker runs applications that use sockets. The sockets get sent over a PPPT link to Slurp. Slurp provides a set of streams to the proxy. The proxy tells the browser's bucket to open up the appropriate sockets. The proxy tells the browser's bucket to open appropriate sockets. The browser opens the sockets as commanded, sockets as demanded. The sockets provide socket-level access. The proxy can now mediate traffic between the attacker's sockets and the browser sockets, and now we get to have fun. We get Nessus over IE, Nessie. We get World of Warcraft over IE, Wowie. We get pretty much anything we want. I'd love to give you the demo, but unfortunately the network conventions are a little bit odd for it. Pull me aside though, I have it all ready. Well, sort of. So what else can we use this for? Doing a quick time check. Oh, you guys have no idea how disturbing this is all going to get. Things other people have mentioned. Click fraud's a real problem. Before we assumed we knew what the browser was doing. We had controls, we had headers the browser was always going to do. Now the browser can make arbitrary TCP sessions, which means the browser can have really arbitrary sockets and can behave in really arbitrary ways. It's very, very hard to detect a suitably compromised browser. The only thing you can do is detect that it's unable to transmit certain cookies. A real browser would know a certain cookie value. A click fraud browser would not. Spam. Yeah, you get port 25 access too, guys. You can start sending, go to a website, you start sending spam. What else is going on? I've been starting to think about what we can use this for. Stealth Tor, you go to a website and you are just sort of included into a global network of connection completers that then just sends the traffic back. We can do some bunch of stuff to protect network neutrality. Peer-to-peer networking, actually, we can do. Java provides UDP support, and Java is giving us the ability to send UDP to arbitrary places. We can create a whole cloud of browsers that are all communicating with one another. Oh, and there's this one thing at a TCP/IP drinking game. IP over spam. Sorry, Grandma, I was a little inebriated. TCP/IP drinking game. And the question I was asked was, how would you get around the Great Firewall of China? Now, the correct answer was, why don't set packets that the Great Firewall is sending? Because it's not actually blocking traffic, it's just trying to send shutdown messages. A trick we're going to exploit later. My answer was a rather more disturbing one. I'm like, China sends a lot of spam and China receives a lot of spam, so why don't we just encapsulate our IP traffic inside of that? This was a joke. And then I'm looking at this, I'm like, well, I'm receiving IP traffic and I can send spam. Oh dear God, I can do this with a browser. Are people actually interested in this whole network neutrality thing? I talked a little about tools to detect violations of network neutrality last year. And it was a total accident. I fell backwards into this. I'm like, oh, I can see when the network's getting slower. I had no idea there was so much interest in this. I really didn't. So I've spent the last year thinking, and you'll note this is not in the slide talk. I say nothing. Last year's method had a bug. I needed to send so much traffic that I caused packets to be dropped on the network. I do try not to send so much traffic that I cause links to die. It turns out that really annoys people. So I started thinking, is there a way I can detect? And then I stopped talking about network neutrality. What we're looking for is provider hostility. If you're sniffing my traffic, you're a hostile network. If you're altering my traffic, you're a hostile network. If you're censoring, if you're slowing it down, you're a hostile network. And man, if you are selling my traffic, you're really hostile. Let me give you a metric for hostility. Would the U.S. Army kill you for doing it? You're probably hostile. So what do we need in order to detect provider hostility? Well, if you go ahead and you download content from 2 different sites at 2 separate speeds, there's too many complicating factors. One has a better host than the other. There is some traffic on the particular route. There's all these factors that are conflated. The basic thing you need in order to find out that that something is happening because of your local provider, the entire rest of the internet has to act exactly the same. So, given identical network paths for 2 websites, and remember, in the real world, websites are not actually hosted identically, is the last mile provider hostile to content from one site versus another? And the things we're trying to do are, first, detect differences in speed, and second, and it's a little bit misstated, detect differences in content. Are things being injected? Someone is out there buying this stuff, because let me tell you, all of us know someone who works for a routing manufacturer, and every routing manufacturer is trying to figure out ways to screw with your traffic. Someone's paying for that screwing. There are repeated news articles about ISPs actually going so far as to replace ads and companies setting themselves up as ad replacers. This is a problem. This is a threat to the actual commercial success of the internet. We have to do something, and believe me, this is not what I set out to do. I'm going to have to bust out some packet stunts to save online advertising. Are you freaking joking? Bring it on. First off, what's the problem? I call it the Times Square effect. Movies that show Times Square, they digitally replace every single advertisement. Why? Because there's no contractual obligation not to, and certainly no one who's watching a movie has any expectation that this is anything but a formulated fictional universe. Now, guess what, guys? Carriers are under no contractual obligation to host websites as they say they are. Man-in-the-middle attacks have been something that the web has been built to assume aren't going to happen. The problem is the providers have realized these are really profitable. Wow! I want each of you to think, Google will not sell at the top ranking on their web page. There is a real demand to be the top link on the web page. People would pay a lot of money to be the top link, but Google won't sell. You have demand and you have unsatisfied supply. People will modify networks to the point that they can make the money instead of Google. And if it happens to hurt their brand, oh, well, that's Google's brand. Oh, well, it's not theirs. The reality of advertisements is that users tolerate them. They're actually okay. Maybe you click on them, maybe you don't, but certainly there's no massive open revolt. And you know what? The people who actually do run ad blockers, believe it or not, those people may not actually be the target market. They're not clicking the ads. The problem is which ads actually do get shown.